Hello, students. So suppose we have a vector space V, and suppose we have U1 is a subspace of V, and U2 is a subspace of V. Maybe more, this will extend, but what we could do is we could take U1 plus U2, but we can also take U1 times U2. We could take the product of U1 and U2. Now, what would the product be? Well, it would mean something in U1, which also happens to be in V because it's a subspace, and something in U2, which would also happen to be in V because, well, U2 is a subspace. So what's maybe an example of something like this? Let's take V to be R3. And let's let U1 be the set of all x1, x2, 0. So that x1 and x2 are reals. And let's let U2 be the set of all 0, x2, x3. So that x2 and x3 are reals. So these are both subspaces of V. And we could take the direct sum of U1 and U2, but we could also take the direct product of U1 and U2. So what happens if I take the direct product of U1 and U2? So U1 cross U2 will be, well, it will be the collection of all possible, and I don't want to use the same letter x1, x2 twice, so I'll say A, B, 0, comma, 0, C, D. So these are pairs of triples, right? Because that's how we get a product. So we get pairs of triples for A, B, C, and D in the real numbers. Okay, so we have a perfectly good vector space here. I know what the dimension is because I could get a basis for U1, right, by taking 1, 0, 0, 1, 0, 0, and 0, 1, 0. That's a basis for U1. And if I were to take 0, 1, 0, and 0, 0, 1, I'd get a basis for U2. So I know that the dimension of U1 equals the dimension of U2 is equal to 2. I also know the dimension of V is 3 because it's R3. Okay, so I want to talk about a map, and it's a natural idea. If I wanted to make a map, from U1 crossed U2 to U1 plus U2. So I want to travel from the product to the sum. Okay, but I want to define this carefully. So I am going to let gamma of U1, U2 to be, well, what might be the simplest idea is just add them together. Just add them together. Okay, so, and in general, I could do this with a number of vector spaces. I could say, hey, if I had more spaces here, I could define gamma to be the map that sends U1, U2 through UN to, well, the sum of whatever the individual pieces are. So how would this work here? Well, I'd send, let's say I had gamma of 0, 1, 0, and 0, 1, 1. Well, what does this do? And yeah, I know there's a lot of parentheses here, but we have a pair of triples and we're putting that inside gamma. So what do we get? We just get the sum. We get 0, 1, 0 plus 0, 1, 1. So that's how our map works, and this would give me 0, 2, 1. Okay? And what if I took gamma of, let's say, 0, 1, 0, 0, minus 1, 0? So this would give me, well, 0, 1, 0 plus 0 minus 1, 0. So this would give me 0, 0, 0. Oh, look what I got. I got the 0 in V, which is R3. And this is not 0 in U1 crossed U2. So what else do I know? Well, if I did take the 0, like what is the 0 in U1 crossed with U2? Well, it's this, right? All zeros. That also goes to 0. So this is not injective. But let's think about this a moment. This should have a certain feeling, because look, this here, this part of it is taking place in U1 plus U2. So we had a special name. So, well, I meant this and this. I don't really care about the 0, 2, 1, but that also took place in U1 plus U2. All of these three things took place in U1 plus U2. But I care about the last two. I care about the fact that I have 0, 1, 0 plus 0 minus 1, 0 equal to 0, 0, 0 plus 0, 0, 0. And they're both equal to the 0, which is 0, 0, 0 here. So we had a special name in U1 plus U2 if everything could be represented in exactly one way. And what did we call that? Well, we said that instead of it being a sum, we have a direct sum. So what we end up with here is we ended up showing that we did not have a direct sum, but we kind of showed it with this map. And what did we see? Well, we saw two different things went to 0. We basically saw that this map was not injective, and we concluded that the space U1 plus U2 was not direct. Now, you could say, well, no, you didn't just show that the map was not injective. You didn't show that you had two things going to the same thing. You actually showed that you had two things going to 0. Well, we will take care of that with the next result. So let's let U1 through UN be subspaces of a vector space V. And we're just going to define our gamma like we did before. Well, first of all, I'll say where it goes from and to. It goes from U1 through UN to U1 plus all the way to UN by gamma of U1, U2, UN is equal to the sum. I'll just do a dot, dot, dot. Then the sum U1 through UN is direct if and only if gamma is injective. Okay, so that is going to be our theorem, which we have not proved yet. We just saw an example where it happened to be the case that those things coincided. But what this says is, hey, if you have a direct sum, then this map, gamma, happens to be injective. And if gamma is injective, then it's enough to say that this sum is direct. So let's show that next.